Alright, in this video we're going to be going over partial fraction expansion, a technique you learn in Calc 2 that helps take a function like this with a quadratic in the denominator and turn it into two separate terms. So you can then use logarithms when you're looking for integrals. So that becomes useful in circuits, not for integration so much, but once you run into circuits with capacitors or inductors, it's very difficult to do anything with this in this form. So you want to separate them. And you do that by setting it to two different terms with variables that you don't know yet. So we'll take, say, a over s plus 2 plus b over s minus 1. And now you need to figure out what you can make a and b to make these two, equal equations. And how I do this is just multiply everything by, the lowest common denominator, which is this quadratic right here. So if you multiply a by this, you're left with a times s minus 1. And if you do the same for b, you're left with b times s plus 2. And then you do that with 20s and you're just left with 20s. And then from there the easiest way is just to start eliminating. You can eliminate b by setting s to negative 2. So when you set s to negative 2, a, you'd have negative 2 minus 1 is equal to 20 times negative 2. So that's clearly negative 3a is equal to negative 40. And then from there you just divide, and you can see that a is equal to 40 over 3. And now you're going to do the same thing, except you want to eliminate the a term now to solve for b. So you can set just s equal to 1. And that'll eliminate that term right there. And you'll have b times 1 plus 2 is equal to 20 times 1. So you have 3b is then equal to 20. So b is equal to 20 over 3. And now all you do is plug that back into your AB equation, and you have 40 over 3 over s plus 2 plus 20 over 3 over s minus 1, and that is going to be equal to 20s over s plus 2 times s minus 1. And there you go. In the next video, we'll go over how to take this and use the inverse Laplace transform to get this from the s domain into the time domain.